So in this video, we're going to look at exact differential equations with integrating factors. So you need to have watched the previous video. You need to understand how exact differential equations work before you do this. Because basically what this is going to do is say it's not exact, right? Say m of y does not equal n of x. Before we would just leave it. We'd just say not exact, we don't know how to solve it. Well, now we do. Now we will know how to solve it. And I'll show you right now. So let's just look at an example. So to start off, I'm going to do the entire proof on how to do this. I'm going to go through everything, the whole proof. It's very long. It could be very confusing, but we're going to go through the entire thing. And then I'm going to go through a few examples. I don't know how many yet. And then we'll just I'll show you the shortcut way, the way that I'm used to doing it. So anyways, I have notes here on from my professor on the proof. So let's go through it together here. So for this example, the long way, 3xy plus y squared. So let me go the full proof, full example without shortcuts. Okay, so 3xy plus y squared plus x squared plus xy times y prime is equal to 0. So this is the example that my professor gave us. So let's see if it's exact. So m of m of y is 3x plus 2y. N of x is 2x plus y. Well, those aren't equal, so it's not exact, right? So now this is where it changes. So it's not exact. So we're going to look for a function mu such that mu times m plus ny prime is equal to 0. Then it is exact. So we're going to assume mu depends only on x. So we're going to have mu of x is equal to mu. So now, if I rewrite this now, we're going to have mu of x times 3xy plus y squared plus x squared plus xy. Basically, what we're doing is we're going to find some mu that we can multiply both m and n by, that'll make both of them exact. It'll turn it into an exact equation, so then we can solve it later like how we are used to. So this will become our new this is m, right? Yeah. Our new n, and this will become our new m, right? My professor called it m twiggle and n twiggle. Okay, so now we want m of y to equal n of x, right? So if we take mu of x times 3x plus 2y, right? We took the partial with respect to y, set it equal to with respect to x. Now, with respect to x, you see we have these mu of x's, right? So before, the mu of x acted as a constant for my. For nx, we're going to have mu prime. We basically have to do the product rule, right? We have to do the product rule for this. Wait 1 minute. Something doesn't seem right. X squared plus 2. I think I might have either yeah, that's right. This should be m. This should be m. I wrote them in my notes backwards or my professor did. But I have them backwards in my notes. All right. I was going to say that doesn't seem right. That should be our n. And plus the y prime is not included in that. Okay, so yeah, that makes more sense. This is the derivative of the partial of this. Yeah. Okay, now is equal to n of x. So we're gonna have to use the product rule, right? So the second times the derivative of the first. I might run out of space here. Plus the first times the derivative of the second, this time with respect to x only. That will be 2x plus y. Oh, kind of ran out of space there. That's mu of x times 2x plus y. Okay. So now we have this. Let me move some things over. So let me get the. So let me. We can also remember mu of x is equal to mu, right? So we know it's a function of x, but let's just rewrite it like this to save ourselves some space here. So we have mu times 3x plus 2y, and I'm going to subtract this other term over. This is equal to mu prime of x times x squared plus xy. Okay, so now let's see here. What's next? Okay, so we can simplify this, right? If you look at the inside of what's inside the mu's, we have 3x minus 2x. That's just x. We have 2y minus y. That is just y. Is equal to mu prime. Oh, I didn't mean to put that x there. Mu prime times x squared plus xy. Now, let's isolate y prime. So, I mean mu, that's not a y, that's mu. Mu prime is equal to mu times x plus y over x squared plus xy. And now we can simplify this, right? Excuse me. We can simplify this now. So if we do, this is equal to mu times x plus y. If we take out x on the denominator, that's x plus y. This cancels. We're left with mu prime is equal to mu over x, right? I'm going to write it like this. So this is an important step, right? This is an important step right here. Actually, so you'll see why I'm boxing this. We're going to need this later on. But anyways, if we now go back to our original function here, so we had mu times 3x plus 2y? Yeah, so I'm looking over here. I'm looking at this right here again. So mu times 3x plus 2y minus mu times 2x plus y is equal to mu prime times x squared plus xy. So I brought this whole thing back down here. And now, looking at this, that's our my. Hold on, let me see something here. 3x plus 2y. Okay, apparently. Oh, okay, I see. So we're going to think of this as my, think of this as nx, and just think of this as n. I'm not entirely sure where this comes from. My professor just wrote it down. This is part of the proof. Like I said, this is confusing. I don't do this every time. This is the first time I'm doing this in a year. I'm gonna be honest with you. So this here, I'm gonna rewrite this now. We have mu times my minus mu times nx is equal to mu prime times n. Right? So let's oh, you're gonna see why I boxed this thing up here now in a second. I see now. This is pretty cool actually. So we're gonna have mu times my minus nx, right? You see how I pulled that mu out of there? But I'm gonna now divide the whole thing by n. And you're gonna notice that this has to be independent of y. Must be independent of y so that mu exists. Okay, so oh, hold on. I see where we got this from now. I see where we got the my, nx, and n from. If you look back up here, if you look back up at our original m and n up here, this is our original m, this is our original n, right? Oops. Oh, jeez. If you look back at that, if we take the partial of m with respect to y, it's going to be 3x plus 2y. Take the partial of n with respect to x, it's going to be, I did it up here, didn't I? Yeah, up here, it's 2x plus 2y. See that? Look how cool that is. It's 2x plus 2y. That's where that comes from. And n is x squared plus xy, right? That's where those come from. So those do come from somewhere. I was just thinking because this does matter. In other cases, it might be flipped. Nx and my might be over here, and this might be m. So that's where you're gonna notice that we have two possible scenarios for both of these. It's either gonna be this way, or it's gonna be the other way. If it's this way, if we're left with my minus nx over n, then then it must be independent of y. Okay. And you'll see what I mean by that in a minute. So this is the reason why I boxed this up here. Is because you'll notice that these two equations right here are very similar, right? So like we're gonna relate. How am I gonna do this? We're gonna relate these two together here. I'm trying to see what he did here. Okay, so I think after looking at it for a minute, I paused the video, looked at it for a minute. I think I see what he did here. Okay, so we have mu prime is equal to mu prime. Okay, so let's set the mu primes equal to each other. So we have mu of 1 over x is equal to mu of n y minus nx over n. Where does that come from? Give me 1 second. Okay, I think we're good. Looks like my professor skipped a few steps here. Okay, yeah, that confused me. So these cancel. These will cancel, and we're left with wait a minute. Wait a minute. Wait a minute. Yeah, that mu of Oh, wait a minute. We are if you look back up here, when we did this step right here, this is this down here. He just showed it that this is the formula. He just wanted to show that this is the formula, right? This is the formula right here. Okay? This is the formula. This up here was when we actually did it up here. So let's go back to that there then. So, okay, so then this right here is what we have. Oh, okay, so let's take this, let's box this off. I see. Let's box this off. This is just a show like what the formula is. Okay? So this is where we actually are. So it must be, so this right here must be independent of y. And guess what? It is. Because if you look up here, when we did this my minus nx over n, which we did up here, we actually, it actually reduced so that all the y's will end up canceling and we're just left in terms of x. So it's independent of y, right? Okay, now I see what to do. I see the light. Okay, so we have mu prime. This is actually pretty cool. I never actually really looked at this before. I only kind of just used the formulas. So now we have this, right? We'll go back to here. We need to we need to solve for mu. Well, I guess we integrate both sides, right? Yeah. I guess we integrate both sides. This will become mu. And this is with respect to, I think, x, right? I don't know. Well, I mean, we'll be left with this will end up being mu plus c, right? Is equal to because this is like saying d mu, right? Yeah. So then this is like mu plus c. So then we get on this on the right side here we'll have what happens with that mu? I'm so confused what my professor did here. He has the natural log of x, which I assume comes from this side, is equal to mu plus c. Oh, okay. I see what he did. Forget about this. Let me rewrite this. This is actually separable. So we can rewrite this as, I'm going to take that right side here, move it over here. This is d mu dx. This is mu 1 over x, right? So then this will be, we separate it, right? So we have d mu over, right? But that mu, that has to be right, is equal to 1 over x dx, right? That gives us our natural log there. But 1 over mu, that would be then the natural log of mu, though. Wouldn't it be? Yeah, it would be. I'm not too sure where you got that from. Oh. Okay, this is right. I must have wrote it down wrong in my notes. So yeah, this would be the natural log of mu. Yeah, this is right. Yeah, I don't know what I was doing over there. Yeah, this is right. This is right. I have it wrong in my notes. Is equal to, yeah, this is right. Plus c, because then for these, I'm just looking at my textbook. The c, I don't know. They don't include it. They skip that step. They skip the whole. They skip the whole thing, but my professor said that c is equal to 1. Not too sure why, to be honest, but if we take the if we exponentiate both sides, that leaves us with mu is equal to x, right? So now we got our integrating factor. After all that work, after 20 minutes, right? We got our integrating factor. All this work, we got our integrating factor. Well, now that we have our integrating factor, let's try and see if it's exact now. So let's go back to our original thing here. Let me what's that doing over here? Let me copy this. Bring it down here. Let's multiply it by x, right? Because the formula says that mu is multiplied by both of them. So now let's multiply both of these by x now. So let's distribute. So we have 3x squared y plus y squared x plus x cubed plus x cubed y prime is equal to 0. So now, this is our new... was this n or m? I forget. I always forget. That's m. Okay, so this is our new m. And this is our new n. So this is n tweedle. And m tweedle. Okay? So now, let's see if m tweedle y is equal to n tweedle x. Well, m tweedle y, so the partial of m with respect to y, m tweedle with respect to y, is 3x squared plus, with respect to y, that's 2yx. I think it definitely is. I can tell just by looking at this, right? With respect to x, that's 3x squared y. Oh, wait. Wait a minute. What did I do wrong? That's 3, with respect to x, 3x squared. Did I miss something on the last one? Oh, I did. With respect to y. No, that's 3x squared plus 2yx. Oh my god, I see. X times x is x squared, right? Jeez, it's getting pretty late. I'm getting tired here. Yeah, and then that y is still there. Right? That's no longer a 3, that's now a 2xy. And look at that. Look at that. M tweedle y is equal to n tweedle x. It's exact. So now you're able to actually go through it. Actually, after doing it this way, I kind of prefer this way almost than doing the shortcut. Because you don't have to memorize any formulas then. You just go right to here. You multiply both of them by mu. And then you just you set both of them equal to each other. That is actually so much easier. I'm not gonna lie, that is so much easier. Wow. Because most professors these days, they just give you the formula and they're just like, use both. There's two formulas for these. It's either this one or the other case where you have what's it go? N of x minus m of y is equal to m, and that'll just, and so the other formula will look like I'll write it over here. The other formula will look like mu times, this is n of x minus m of y over m is equal to mu prime. So that you have there's two scenarios that can happen here, and that's it. I honestly prefer doing it this way now. I think it's honestly easier. It's a little bit more work, yeah, but I think it's honestly easier. Okay, well, anyways, I'm gonna stop this video here. This took way longer than I thought it was going to. So now that we proved that this is exact, now we can actually go ahead and solve it, just like how we did in the last video. But I'm just gonna stop here, and I'm just gonna stop here for now because the rest of it's pretty simple, straightforward. You go back to the last video if you need help with it. But this was the long method, long thorough method, right? So in the next video, I'm just going to start with the formulas in the next video. And I'm going to just use the formulas in the way that I used to do it to solve some examples. I might actually do it both ways. You know, I'll see what I'm feeling like. I'm gonna do it tomorrow. I'll see what I feel like doing for those. Alright, so I hope you enjoyed this video. You know, whatever method works for you. If you want to start with the formula, but then you have to think about which one you need. And that's what I'll show that in the next video. I think I'm gonna do it this way, but I'm gonna show like how you do it with just starting with the formula. I'll do it both ways. Alright, hope you enjoyed the video.